Hi guys. So what we're going to do now is we're going to start our last unit, which is going to look at actually some topics that you've seen earlier this year. So the first thing we're going to do is we're going to kind of look back at graphing, because graphing I think is something we've kind of struggled with so far this year. And what we're going to look at is just some of the terminology that we've talked about and kind of review some of that. And we're also just going to look at transformations from function notation form to review what those transformations mean and how they affect our graphs so that we can apply them to any parent function when we look at piecewise functions next class. So to start, what we're going to do is we're going to take a function that doesn't really look like one of your typical graphs, but we're just going to review some of this vocabulary that you've done throughout the year. This is going to hit all of the main vocabulary. The biggest one this is going to leave off, though, is end behavior, just because these graphs don't really continue in a particular direction, so we're not really looking at end behavior since they have a clear start and stop. But we'll talk about end behavior again once we get to parent functions. All right, so first of all, domain. Remember, domain refers to our x values. That is from left to right. So the farthest left point on this graph is -3. The farthest this graph goes to the right is 3. Because it actually touches both of those points, we're going to use brackets. All right, range. Range is bottom to top. So the lowest point on this graph is -2. The highest point on this graph is +2. So our range is going to be from -2 to 2. The intervals where the graph is decreasing. So when we say intervals, that is the x values. So we are saying from what x until what x is your graph decreasing. So the sections where it's decreasing is when the y's are getting smaller. So it's easy to see that this section and this section and this section, that's where my graph is decreasing. Okay, but to write the intervals, I'm listing the x values where that's happening. So that section, that first purple part, that is from -2 to -1. That's the first interval. Then our next interval would be from 0 to 1. Then my next interval would be from 2 to 3. All right? Where this graph is increasing, okay, that is going to be, again, where your y values are getting larger. So here my graph is increasing. Here my graph is increasing, and here my graph is increasing. So the intervals, again, it's the x values where that's happening. So from -3 to -2, it's increasing. From -1 to 0, it's increasing. And from 1 to 2, your graph is increasing. Right. Now, while those aren't that difficult on their own, they sometimes get confused with these next two sections of intervals. So again, intervals, we're saying the x values. Okay, so from what x until what x. It says the intervals where the f of x is positive. Where it's positive is when the y values are positive, which means when your graph is above the x-axis, which is those sections of my graph. So the x values there would be from -3 until that x-intercept. Now, this one's a little bit trickier because we don't really know what that x-intercept is. And we can estimate it, but I want to be able to find it exactly. So to find that exactly, we're going to review some stuff from Algebra 1. Okay, that segment there is a line. Okay, that line has a slope of a -3 because I'm going down 3 and right 1. If I wanted to write the equation of that line, it would be y equals -3x plus or minus the y-intercept. If I continued that slope, the y-intercept would be down there at -4. So that section of that graph is at -3x minus 4. So if I want to know exactly what that intercept is, then I can set y equal to 0 and solve. So I get that 4 is equal to -3x. So I know that this point right there is exactly -4/3. Okay, and that is where my graph is positive. Okay, if I want to find the other section, again, I need to know that y-intercept. Well, I need to figure out what that line is. That line has a slope of 3. Okay, if I continued that same pattern, this would be my y-intercept, which is -5. So if I solved for x, just set it equal to 0 and solve for x, then I get that x is equal to 5/3. Or 1 2/3, that's where that is. and then it stays positive until 3. Now again, just looking at the graph, you can estimate it, but I want you guys to be familiar with how to write the equation of the line, because that's what we're going to do next class when we get to piecewise functions. That's why I kind of want to introduce that a little bit there. All right. The intervals where it's negative is where your graph is below the axis. So our graph is below the axis in all of those points. Okay. Now again, we want it to be negative, not necessarily 0. So I'm going to write this as -4/3, and then at 0, it's not actually negative, it's just 0. So then I'm going to say union 0, and then it stays negative until I get to that 5/3 mark. Okay, so the biggest thing to get out of this, positive and negative refers to when your graph is above or below the axis. Increasing and decreasing refers to is your graph getting bigger or is your graph getting smaller. But again, for all 4 of these, what we filled in those blanks, everything in those parentheses were x values. So we would read that from the x value of -2 to the x value of -1, your graph is decreasing. From the x value of 0 until the x value of 1, your graph is decreasing, which means the y values are getting smaller. All right. So let's look at a couple more things. So evaluate f of -1. f of -1 means when x equals -1, what does y equal? So I go to my graph, I go to -1. When x is -1, the y value is also -1. All right. Find all values where f of x equals 2. That means find the x's that give you a y coordinate of 2. So when y equals 2, x equals blank. Whereas up here, this was x equals -1, so y equals blank. It just happened to be the same thing. Okay, so let's go back to our graph. When y is 2, there's only one place where it touches, and that is the x coordinate of -2. All right. Average rate of change is another way of saying slope. So the average rate of change on the interval -1 to 3 is actually a very simple question that you answered in Algebra 1. It's saying from the x value of -1 until the x value of 3, how are your y's changing? Okay, what's the average rate of change? What's the slope? So from -1, there's the point on my graph, until the x value of 3, which is this point on my graph. The average rate of change is just my slope there. Slope is rise over run, so I went up 1 and over 1, 2, 3, 4. So that average rate of change is 1/4. You also can find that algebraically, change in y's over change in x's. So y2 minus y1 over x2 minus x1 also gives you 1/4. Okay, so average rate of change is slope, but again, intervals are telling you the x values from this x value until this x value. Okay, relative minimum, relative maximum. If you remember, those are kind of our tops and bottoms of hills. Okay, it's not necessarily the highest point on the entire graph, but it's the highest or lowest point relative to the points around it. Okay, so some examples of some relative minimum. This point right here would be a relative minimum because it is not the lowest point in the graph, but it's the smallest point to the points closest to it. Okay, relative minimum, the actual value of the minimum is 0. Okay, where it happens, okay, is when x equals -3. So where it is -3, how big it is 0. There is another relative minimum over here. Okay, so there's a relative minimum, -1 is the value. It happens when x equals -1. And then there's another minimum over there. Okay, that value is 0. It happens when x equals 3. Okay, the absolute minimum would be the absolute lowest point on that graph, which is that point down there. So the absolute minimum would be -2. And again, that happens when x equals 1. Okay, let's talk about our maximums. Okay, so my relative maximums would be like this point right here or this point right here, because they're the highest points according to, or highest points relative to the points near it. So one of those would be 0, and that happens when x equals 0. Another one of those would be 1, and that happens when x equals 2. The absolute maximum, the absolute highest point on the entire graph, would be this top point right there. And that has a value of 2, and that occurs when x equals -2. All right, so that's reviewing a lot of our vocab that we've gone through during the year. On your notes page, you'll see kind of a little list that kind of helps you remember how to find some of those things. The next thing we're going to look at is transformations, which is something you've been doing all year, but instead of looking at them for a specific function, what we're going to do today is we're going to take a graph very similar to the picture you just saw, and we're going to apply these transformations in function notation. But this is the stuff that you've been seeing throughout the year, but it's important that you guys understand what these things mean. So first of all, f of x minus h, okay, that notation is saying that is shifting to the right by h. The way you would apply that change is you would add h to the x-coordinate of whatever graph that you have, okay? Because think about the horizontal changes, what we're doing, we're trying to undo what's in the parentheses. We're trying to get the x by itself. So if I were to get x by itself, I would add h, okay? Then if I look at this one down here, okay, that b times x, if that b value is greater than 1, that is a horizontal compression. If it's in between 0 and 1, it's a horizontal stretch. Okay, this is backwards from what you're used to it being. So what you're going to do with that value is you're going to take your x-coordinate, you're going to divide by b. So all this x-coordinate stuff is typically backwards. So if it's x minus h, you add h. X plus h, you subtract h. B times x, you're going to divide by b. Then f of negative x, if the negative is inside there, that's going to be a reflection over the y-axis. And then our vertical changes happen away from the x, outside of those parentheses, okay? If I multiply on the outside, that would be a vertical stretch. If it's greater than 1, that would be a vertical compression. The operation that you would do is you would multiply by that value. So when it comes to order, we've talked about this a little bit. I think what's going to be simplest for you guys, if you see a b value, so if you see a value multiplied like this, what you're going to want to do is you're going to want to factor that out, because that way we don't have to stress too much about order. We can always multiply first and then add and subtract second for both our x-coordinate and our y-coordinate. So what I mean by that is if you see something like f of 2x minus 8, okay, instead of worrying about our order, what I would do is I would factor out that 2 and make that x minus 4. That's the same expression, because that 2, if I went back and multiplied it and distributed it, I would get 2x minus 8. But by writing it this way, that allows me now, hey, I can take my x-coordinate, multiply it by 2, and then I can add 4. I'm still going to get the same result as if I added 8 and then divided by 2. Oh, sorry, I wrote multiplied by 2, and I meant divide by 2. So you would still get the same answer for your final value, but if you factor out that b value first, then you can always multiply first for both your x's and your y's. Okay, so we'll look at some examples of this. So what we're going to do is we're going to take that same graph we just looked at and we're going to apply these transformations. So the first one I have f of x plus 1. So the first thing you need to recognize is what kind of a transformation is that. So f of x plus 1 is a horizontal transformation because it's next to the x, and it's going to go to the left 1. So this graph is going to go left 1. What that means is on all of the points on that graph, I'm going to take the x-coordinate and I'm going to subtract 1. So there's two ways you can do it. If you're more of a visual person, it may make more sense to you to take every point on this graph and just shift it 1 to the left. And that's exactly what we're doing, and that's your new graph. All right, and we would just draw it on our new graph. If you are more of an algebra person than a visual person, you may want to actually write the coordinates of these points down. Okay, and this might make it easier for some of our more complicated transformations. So these points are -3, 0, -2, 2, -1, -1, 0, 0, 1, -2, 2, 1, and 3, 0. So to graph this, literally what I'm doing when I shift it left, I am subtracting 1 from my x-coordinate. So negative 3, 0 becomes negative 4, 0. Negative 2, 2 becomes negative 3, 2. I'm not changing the y-coordinate in any way because the only transformation here is going left 1. Negative 1 becomes negative 2, negative 1, 0, 0, negative 1, 0. This becomes 0, negative 2, 1, 1, and 2, 0. Connect my dots. And there's the same graph, just shifted left 1. All right, now let's look at B. B is not going to change the x-coordinate at all. This is only going to change the y-coordinate. That 1/2 is a vertical compression by 1/2, which means I'm going to take my y-coordinate and I'm going to divide it by 2. All right, so again, if you're visual, you can just look at that graph and take those points and take the height and make half the height. If you want to look at it algebraically, I'm going to take those coordinates. Negative 3, 0 is still going to be negative 3, 0. Negative 2, 2 is now going to become negative 2, 1 because I'm taking that height and multiplying it or dividing it by 2. Negative 1 is going to become negative 1, negative 1/2. 0, 0, 0, 0. 1, negative 2 is 1, negative 1. 2, 1 is 2, 1/2, and 3, 0 is still 3, 0. So again, same graph, same location horizontally, but it's basically just squished vertically. All right, so let's look at a couple other transformations. Same graph, this time it's negative f of x. That's going to affect our y-coordinates. It's going to change the y-coordinate to be negative. So this is going to be reflected over the x. So I'm going to take those same points and I'm just going to flip them over the y-axis. Okay, I'm taking the y-coordinate that was there and I'm making it positive. I am not changing my x-coordinates at all here. I am only changing my y-coordinates. And there's my same graph, just flipped over. So on D, we're going to start looking at multiple transformations. Okay, so this has both a horizontal and a vertical change. So horizontal, I'm going to go to the right one. Vertical, I'm going to go up 2. All right, so what this is going to do to your actual coordinates, I would take the x-coordinate and I would add 1. I'm going to take the y-coordinate and I'm going to add 2. So I'm going to start with those same original points. So those original points were negative 3, 0. Negative 2, 2, negative 1, negative 1. I'm going to stop there for right now, just so you can see what we're doing. So I'm going to take the x-coordinate for each of these and add 1. That becomes negative 2, negative 1, 0, 1. Then I'm going to take the y-coordinate and I'm going to add 2. So 0 becomes 2, 4, 1, 2. And I'm going to plot those new points. All right, and then I'm going to finish up my last ones. So 1, negative 2. Okay, so originally that point was 1, negative 2. I'm going to go right 1 and up 2. Then I have 2, 1. I'm going to go right 1 and up 2. And then I have my last point. I'm going to go right 1 and up 2. Connect my dots. And there's that same graph, just shifted right 1 up 2. E only has one transformation, but it's probably the most missed transformation. 2 times x means it is a horizontal compression. Okay, horizontal compression by 1/2. That means I'm going to take my x's and divide them by 2, not multiply them by 2. So that is going to squish your graph horizontally. So take those same x-coordinates. So negative 3 cuts in half to negative 1/2. Negative 2 squishes in half and becomes 1. Negative 1 squishes to negative 1/2. 0 stays 0. All right. 1 gets cut to 1/2. 2 gets cut to 1. And 3 squishes to 0. So same shape, but my graph, did not go low enough there. There we go. And there's my graph. All right, so my last ones, just having multiple transformations again. So looking at f, 2f of negative x plus 1. So this has a few horizontal and vertical transformations. So let's look at horizontal changes first. The only change that's going to affect my x-coordinate is that negative. So this is going to be a reflection over the y-axis, which means I'm going to have a negative x-coordinate. And that's the only change to my x-coordinates. To my y-coordinates, I'm going to have a vertical stretch by 2, and I'm going to go up 1. So what that's going to do to my y-coordinates, I would multiply by 2, and then I would add 1. So I'm going to take, again, those original points. So negative 3, 0, negative 2, 2, negative 1, negative 1, 0, 0. All right, same points, and I'm going to just apply those changes. So the x-coordinate, okay, I change my x-coordinate by making it positive. Right. My my y-coordinate, I multiply by 2, then I add 1. So 0 times 2 plus 1. 2 times 2 plus 1. Negative 1 times 2 is negative 2 plus 1. 0 times 2 plus 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So let me go ahead and plot those ones. Right, and then my last 2 points, ran out of space. Let me add those down here because we're going to use those for the next points. I've got 2, 1, and 3, 0. So I'm going to apply those same transformations. Multiply by 2, add 1. Multiply by 2, add 1. So negative 2, 3. And negative 3, 1. And there's my graph. So it's the same graph, but it has been reflected over the y, it has been shifted up 1, and it has been stretched by 2 vertically. All right, on G, similar concept, but what we have, this is what I was talking about with factoring out that value. Now, there's 2 different ways that you could work this out. If you keep it the way it is, you would have to do your shift first. Since that gets a little complicated trying to remember correct order, I think it's going to be easiest for us instead, whatever's in front of that x, we're going to factor it out. So I'm going to make this, if that negative comes out, whoops, not the x. If that negative comes out, I'm left with x plus 1 in parentheses, which means I'm still reflecting over the x. Okay, but then I'm going to go left 1. If you went right 1 and then afterwards reflected over the y, you would still end up in the same place. But this order, I think, makes it a little bit easier because now when I do my math, I'm going to do a negative x-coordinate and then I'm going to subtract 1. It's the same thing again if you were to do it the opposite order, but this allows us to be able to always multiply and divide first, and then we can just add and subtract second. We don't have to worry about the order changing between our x and our y coordinates. So we're going to take those same points. We're going to do a negative x-coordinate and then subtract 1. So positive 3 minus 1. Positive 2 minus 1. Positive 1 minus 1. 0 minus 1. And you'll probably notice a pattern that's happening here. But if you notice, the spacing of these points does not change. They're still one apart each time. The only time the spacing in between them is going to change is if there's a horizontal stretch or compression. But I just want you guys to kind of see what's actually happening here. All right, and then my y-coordinates are not changing. And then it's going to plot my points. Yeah, I made a negative 1 instead of a positive 1. There we go. All right, the last one has it all on there. So every type of change we could possibly make. So what I'm going to go ahead and do is write these transformations. I'm going to write the transformations to my x's first, which means I'm going to factor out that 1/2. So if I divide 1/2, negative 1 divided by 1/2 would be 2. Because dividing by 1/2 is multiplying by 2. All right, so the order here, okay, I would take my x-coordinate, I would multiply by 2, then I would add 2. If you added 1 and then after that multiply by 2, you would still get to the same place. But again, multiplying first I think is going to be simpler for us. On my y-coordinate, I'm going to make my y-coordinate negative, and then I'm going to add 1. All right, so that means here, applying those changes, so 2 times x plus 2, so negative 6 plus 2, negative 4 plus 2, negative 1 times 2 plus 2. And we're going to go a little bit off the graph, and that's okay. Y-coordinate, make it negative, add 1. Negative 2 plus 1. Positive 1 plus 1. And then just plot our points. And again, we're off the graph a little, but that's okay. And I'm realizing I made a mistake on one of my points. Whoops. Back over here, if I do negative 2, if I make that negative, so that becomes positive 2 plus 1, that's going to be at 4, 3. That's going to make this look right. There we go. And then negative, I think on those last points I just forgot to make them negative first. Negative 1 plus 2 puts me at, oh sorry, negative 1 plus 1 puts me at 6, 0. There we go. And there is my graph. And so the transformations that we're applying here, those are going to work for all the functions that we've done. It's the functions that you've been doing. But when you look at them generally, it's important to understand the notation. So remember, everything that's in the parentheses is horizontal. If there's a number or a negative in front of the x, we want to factor it out so that we can multiply first and then we can add after. Everything that happens outside of those parentheses, that's what's going to affect our y, and that's what's going to be our vertical transformations.